Trigonometry, three-dimensional trigonometry, introduction exercise. This is an exercise involving three-dimensional trigonometry problems. There are 5 questions altogether. The first 3 questions come up on this screen, so pause the video at this point and attempt them. When you restart the video, the next questions will come up. Okay, these are the remaining 2 questions. If you pause the video now, you can attempt them. When you restart the video, I'll go through the solutions. Okay, let's go through the solutions. In question 1, we're given a cube with sides 10 centimeters. In part 1, we have to find the length of a diagonal joining the opposite vertices of the cube. To solve this, let the diagonal be HB. We can see that we could work out the length HB if we knew the sides HD and DB of the triangle HDB. But we need to work out the length DB. And we can do that by considering the triangle ABD. This triangle has 2 sides that are 10 centimeters long. If we draw a plan view of the base, we can clearly see we've got a right-angled triangle with 2 10 centimeter sides. So we can use Pythagoras' theorem. Now that says BD squared equals 10 squared plus 10 squared. So BD squared is equal to 100 plus 100 or 200, which means BD is the square root of 200. BD is 14.142. Now let's consider the triangle HDB. Now this triangle has one side 10 centimeters and the other side the square root of 200. So let's draw a plan view of the triangle HDB. We can see that it's a right-angled triangle. So we can again use Pythagoras' theorem. Now that means HB squared equals 10 squared plus the square root of 200 squared. Or HB squared is 100 plus 200, which is 300. So HB is the square root of 300, which is equal to 17.321. So if we round off our answer to 1 decimal place, that gives us a diagonal length of 17.3 centimeters. Now, for part 2, we want to find the angle between a diagonal and one of the adjacent edges of the cube. So, to find the angle between the diagonal and an edge, consider the angle BHD. In the diagrams, we can mark this as the angle theta. Now, the side DB is 14.1421 centimeters long, and that's the opposite side from the angle theta. The side HD is 10 centimeters, and that's the adjacent side. Now we know the tangent is the opposite over the adjacent. So tangent of theta is equal to 14.1421 over 10, or the tangent of theta is 1.41421. So theta is the inverse tangent of that, and from a calculator we get theta is 54.736 degrees. If we round that off to 1 decimal place, we have the angle between the diagonal and an edge is 54.7 degrees. Now for part 3, we want to find the angle between a diagonal and one of the faces of the cube. So for an angle between a diagonal and a face, consider the angle HBD. Now in triangle HBD, the angle HBD plus 54.736 degrees plus 90 degrees is equal to 180 degrees, angle sum of triangle. So the angle HBD is equal to 90 minus 54.736, and so the angle HBD is 35.264 degrees, or rounding that off to 1 decimal place, the angle between a diagonal and a face is equal to 35.3 degrees. In question 2, we're given a diagram and we're told a post CD stands on one side of a river 6 meters wide. A is a point directly opposite it across the river. The angle of elevation of C from A is 40 degrees. B is another point on the river bank on the same side as A. From B, the angle of elevation of C is 20 degrees. Calculate the length AB. Well, to solve this, we first need to work out the height h of the post. We know that the river is 6 meters wide. So if we consider the triangle ADC, we should first draw a flat diagram. Now we can see it's a right angle triangle with an angle of 40 degrees. H, the height, is the side that is opposite the 40 degrees, and the 6 meters is adjacent to the 40 degrees. Now we know the tangent of an angle is the opposite over the adjacent, so the tangent of 40 is equal to h over 6. If we multiply both sides by 6, we get 6 times tangent of 40 equals h, and if we work that out on a calculator, we get h is equal to 5.0346 meters. Now we can use this to find the distance BD. So let's consider the triangle BCD and draw a flat view of it. We see that we have a right angle triangle with an angle of 20 degrees, and the height of the post is the opposite side from the 20 degrees. Now we want to find the length BD, which is the adjacent side, and we know the tangent of an angle is the opposite over the adjacent. So the tangent of 20 degrees is CD over DB, which means that CD is equal to dB times 20 degrees. Now CD is 5.0346. So 5.0346 equals dB times tan 20, and if we divide by tan 20, we get 5.0346 over tan 20 is equal to dB. Now we can work that out on a calculator, and we find dB is equal to 13.832 meters. But we want to work out the length AB. So now consider the triangle ADB. Let's draw a flat view of this. We see it's a right angle triangle, and so we can use Pythagoras' theorem. We have AB squared plus 6 squared is equal to 13.832 squared. So AB squared is equal to 13.832 squared minus 6 squared, which works out to be 155.324. And if we take the square root of both sides, we get AB is equal to 12.463. So, rounding that off to one decimal place, we have AB is equal to 12.5 meters. Now let's look at question 3. A pyramid has a rectangular horizontal base ABCD with dimensions 10 meters by 8 meters. The apex, E, of the pyramid is 6 meters vertically above the center F of the base. In part 1, we have to calculate the length of AF. Now to solve this, to find AF, we need to draw the base ABCD viewed from above. In triangle ABC, using Pythagoras' theorem, we have AC squared equals 10 squared plus 8 squared, which is 100 plus 64, or 164. So, taking the square root, AC is the square root of 164, which is 12.806, but F is the midpoint of AC, so AF is equal to 6.403 meters. Rounding that off to one decimal place, we have AF is equal to 6.4 meters. Now in part 2, we have to calculate the angle the line AE makes with the ground. Now the angle AE makes with the ground is the angle EAF. So if we draw the triangle AEF in flat view, we have AF is equal to 6.403 meters. Now if we label the angle AEF as theta, then the side FE is the opposite side and the side AF is the adjacent side. Now we know the tangent of an angle is the opposite over the adjacent, and so tangent of theta is equal to 6 over 6.403. Now if we take the inverse tan of both sides, we get theta is the inverse tangent of 6 over 6.403, which means theta is equal to 43.139 degrees. Now if we round that off to one decimal place, we get theta is equal to 43.1 degrees. Now in part 3, we're asked to calculate the angle the surface EBC makes with the ground. To do this, we're going to have to draw a line from F perpendicular to BC at the point G and join GE. Now we want to consider the triangle EFG, so let's draw a flat view of that triangle. Now we have that FG is half the width of the pyramid, so it's 5 meters, and EF is the height of the pyramid, so it's 6 meters. We see that it's a right angle triangle. We're trying to find the angle EGF, let's call that phi. EF is the opposite side from phi, and FG is the adjacent side from phi. Now we know the opposite over the adjacent is the tangent of the angle. So we have tangent of phi is equal to 6 over 5, and if we take the inverse tangent of both sides, that gives us phi equals the inverse tangent of 6 over 5, which means if we work it out on a calculator, phi is equal to 50.154 degrees. Or rounding that off to one decimal place, phi is equal to 50.2 degrees. Okay, let's go through question 4. A radio mast at sea stands 250 meters north of a point A on level ground. The angle of elevation of the top of the mast D from A is 15 degrees. A point B lies 180 meters from A on a bearing of 60 degrees. Find the angle of elevation of the top of the mast from B. Now to solve this, we need to find the angle of elevation theta in the diagram. And to do that, we need two sides of the triangle BCD. So, first of all, let's find the length of the side CD. Consider the triangle ACD. We need to draw a plan view, and then we can see it's a right angle triangle with an angle of 15 degrees. Now, the height CD is the side opposite 15 degrees, and the 250 meters is the side adjacent to the 15 degrees. And we know the tangent of an angle is the opposite over the adjacent. So that gives us tangent of 15 is equal to h over 250, or h over 250 is equal to tan of 15. If we multiply both sides by 250, we get h is 250 times tan 15, which if we work it out on a calculator comes out to be 66.99 meters. We can mark that in the diagram. Now let's work out the side CB. Consider the triangle ABC. If we draw a flat sketch of it, we see that it doesn't have a right angle. We've got a triangle with two sides given, 250 meters and 180 meters, an angle given, 60 degrees, and we're asked to work out the third side. To do that, we're going to have to use the cosine rule. Now that states a squared equals b squared plus c squared minus 2bc cos a. And we have the side B is equal to 250 metres, the side C is equal to 180 metres, and the angle A is 60 degrees. So substituting it in, we have a squared equals 250 squared plus 180 squared minus 2 times 250 times 180 times the cosine of 60. And that works out to be a squared is equal to 49,900. If we take the square root, we get a is equal to 223.38. We can mark that in the diagram. Now, if we consider the triangle BCD, we've got two sides now. The height is 66.99 metres, and that's the opposite side. The other side we've got is 223.38 metres, and that's adjacent to the angle that we need. Now we know that the tangent of an angle is equal to the opposite over the adjacent. So tangent of theta is equal to 66.99 over 223.38. And if we take the inverse tangent of both sides, we get theta is equal to tan minus 1 of 66.99 over 223.38. If we work that out on a calculator, it comes out theta is equal to 16.693 degrees. So if we round it off to one decimal place, we get the angle of elevation is 16.7 degrees. Okay, let's have a look at question number 5. A tent has a rectangular base 3 metres wide by 4 metres long. It has two vertical tent poles that are 2.2 metres long, placed midway across the tent, 0.6 metres from each end. The walls are planes that come down to the ground, as in the diagram. In part 1, we were asked to find the angle the end ABE makes with the ground. Now to solve this, we first mark the point J midway along the side AB. Then we consider the triangle EFJ. Now we need to draw a flat diagram, and we see we've got a right angled triangle. The angle theta is the angle we want. So the side EF, which is the height of the tent, 2.2 metres, is the opposite side, and the side 0.6 metres is the adjacent side. Now, we know the tangent of an angle is the opposite over the adjacent. So the tangent of theta is 2.2 over 0.6. If we take the inverse tangent of both sides and put it into a calculator, we get theta is equal to 74.74 degrees. If we round that off to one decimal place, the angle EJF, which is the angle the side makes with the ground, is equal to 74.7 degrees. Now in part 2, we're asked to find the angle the edge AE makes with the ground. So we need to consider the triangle AJF, and we need to draw a flat diagram. We can see it's a right angle triangle, so using Pythagoras' theorem, we have AF squared is equal to 1.5 squared plus 0.6 squared, which works out AF squared is equal to 2.61. Now if we take the square root of both sides, that gives us AF is equal to 1.6155. Now let's consider the triangle AFE and draw a flat diagram. We see it's a right angle triangle. We want the angle phi, that's the angle the edge makes with the ground, and the side 2.2 metres is opposite phi. The side 1.6155 is the adjacent side, adjacent to phi. Now we know the tangent of an angle is the opposite over the adjacent, so the tangent of phi is 2.2 over 1.6155. Which means if we take the inverse tangent of both sides, phi is the inverse tangent of 2.2 over 1.6155, And if we work that out on a calculator, phi turns out to be 53.709 degrees. If we round that off to one decimal place, the angle EAF, which is the angle we want, is 53.7 degrees. In part 3, it asks us to find the angle BEG. Well, first, let's consider the triangle EFK. Now, the triangle EFK is a right-angled triangle, so we can use Pythagoras' theorem. And we have EK squared is equal to 1.5 squared plus 2.2 squared, which is equal to 7.09. If we take the square root of both sides, we get EK is equal to 2.6627. Now let's consider the triangle EBK. Well, if we draw a flat diagram of it, we see the side EK is 2.6627 meters, and that is the opposite side. The side BK is 0.6 meters, and that's the adjacent side. Now, the tangent of the angle is the opposite over the adjacent, so tangent of alpha is 2.6627 over 0.6, which means alpha is the inverse tangent of that, which turns out to be 77.30 degrees. Now the side EG is parallel to the side BC, so that means the angle BEG is 180 minus alpha. So BEG is 180 minus 77.3 degrees, and that gives us the angle BEG is 102.7 degrees.